Hello everyone, welcome back to another video. Hopefully I don't ramble on too much because I think this is my fourth take. Just trying not to ramble because I have a lot to talk about. Um, so as you can see, things have changed. Maybe not too much, but they've changed a lot structurally. Not necessarily visually. So I've been experimenting a lot with something called spatial hashing, which I'm sure most people have probably heard about hash maps or used them at one point if you've ever coded anything. But they're quite interesting for voxel data because it means that we can store things sparsely. And what sparsely means is that we're not storing everything that ever existed. But we can store things like only the voxels that exist instead of all the random error voxels that don't exist and we don't need anything to do with. Um, but the main issue with hashing is it really has poor cache locality. And what that means is voxels are not located close together in memory. And as well as depending on how you store the data, you can actually triple or quadruple the amount of data you're storing because you also have to store the keys. But instead of doing all of that finicky stuff, you can just go back to traditional good old how we store voxels, which is chunks. Um, and if you take a chunk and you hash its position and store it in a hash table, you can very easily read and write to it in any kind of way that you need possible. And it's near constant time, or if not always constant time, almost always. So it's a lot faster than an octree or a 64 tree. And I know a fair amount of people in the community have dove a lot into octrees and 64 trees, but I think they're pretty universally just not that great. Uh, Especially for just lots of opaque geometry. Um, and this just comes down to the way that GPUs work. I'm sure if GPUs worked in some kind of more compute-based way, that they would be amazing, but unfortunately they don't. Um, the current pipeline that GPUs have right now um, use triangles rasterization. Um, so if you can use any kind of thing with any kind of rendering scheme with triangles and rasterization, is almost always universally faster. So I ended up converting the whole engine to use meshing. Um, Flying here, you can kind of see how it's all just faces. Um, Shout out to Ethan Gore. I'm sure everybody's probably kind of familiar with this technology, but if you haven't, he has some very interesting YouTube videos. You should check him out. He helped me write a few of the parts that I was confused about uh, based on multi-draw and everything. So give him thumbs up. I don't know, a subscription on YouTube. Uh, but anyways, back to that kind of idea of spatial hashing versus octrees. So using triangles and using ray tracing is just the way that things are done, unfortunately, or fortunately, depending on what you're doing. Um, but that means that we kind of have to just use that hardware, and there's not really a faster way of doing things because it's built onto the chip. Um, I feel like there's probably a better way of conveying how and that understanding of how that works. I wish the voxel community um, had better videos on that kind of topic of how that kind of works, because you can quickly get overwhelmed with how many different kind of technologies there are and rendering kinds of ways. For example, when I first started out, I started reading uh, papers like gigavoxels and volumetric rendering based X-ray papers for like medical rendering, but they there's just so much information, especially for just anybody starting off, that there's not really any kind of concrete way of doing things. And if you're just starting off, I'd recommend just following a basic traditional graphics pipeline. It's always going to be the fastest, especially if you're developing games. And then if you still are suffering performance, then start experimenting and reading and getting into deeper technology. Um, but just those papers that are like 10 or 20 years old and you've never seen the technology used before, there's typically a reason why that's never been brought up again, just because we found faster ways of doing it with the way that hardware is progressing. Um, so hopefully that helps somebody out there. Um, I guess that moves on to my next point, uh, which is to dive a little bit deeper into. I want to go into physics more. Believe it or not, when I first started with voxel development, I wanted to create a physics engine, and then I got lost in the rendering because I couldn't figure it out, because I wanted to mainly support ray tracing as well as physics. But rendering physics primitives that are ray traced is like very, very hard to do in real time. So I thought voxels were the way to go. I got super fascinated with the technology, and I kind of just got stuck here. But I really like it. It's very interesting. But that means that now I want to devote a lot more time to working on the physics engine rather than just the rendering, because what the second I moved over from using just ray tracing for primary hits to rasterization, it really just fixed all of the issues I was having with the physics performance. Um, and now, with that kind of finally solidified and out of the way, I feel like I can start moving on to those kind of issues and problems. Um, if anybody has any questions or anything, I guess um, put them down in the comment section. Hopefully, I'll see those and answer them. Um, I'm super excited for where this is going to go and how things are going to happen. I still have a lot planned. Um, but yeah, thank you guys for watching. Um, and I guess I'll see you guys in the next update.